So, hello and welcome to the first audio issue of the Shape Journal. This particular edition is entitled The Nature of Reality. And I'm here today with Jim Schofield, author and philosopher, to talk about his work on that subject. And as a continuation of the last few editions of Shape Journal, which were all to do with systems theory. And with that in mind, I'm going to start by reading some excerpts from Jim's contributions to those, and then I'm going to invite Jim in to discuss some of these ideas and see how they relate to where the theory is going next. Okay, so the first excerpt I'm going to read is from the last issue of Shape Journal, which was entitled The Systems Theory of Everything, Part 6. And the paper I'm going to read you an excerpt from is called Dialectical Materialist Evolution. There's no doubt in my mind that this kind of systems theory, if taken forward beyond these initial ideas, has the potential to be truly revolutionary. It has taken some 2,500 years of mistaken and wholly pluralist misguidance to finally announce this ultimate demise and the impossibility, at least at present, of both a sound and developable truth-revealing approach that will radically transform human understanding of our world, of natural systems and how they develop and evolve. It will also finally extend Marxism beyond its increasingly dogmatic and limited application and towards the radical new science that Marx originally had in mind. Leading on from that, Jim, I think for our listeners, it's probably worth explaining a bit more how the Marxism is relevant to the science and how the science is relevant to the Marxism, because I think for the lay person, they might not think that those two things are related or relatable.
Well, they wouldn't be alone. In fact, throughout my quite long career now, and I'm 83, there's not been any of this sort of thing. It is a new direction, and it's taken me some time to arrive at it. I was early conversion to Marxism because I disagreed with the way I was being taught physics at university. But the real developments for me have been latterly, in the last 20 years or so, and particularly the last 16 when we've been producing Shape as a series of articles on the philosophy involved. And big changes have come about, very, very different to the way that it's normally done. Even by, professionals at university, it is not normal to think of knowledge, understanding, and theories dialectically. They're thought of as being fixed, fixed laws. And when you get something complicated, it's because more than one law is acting simultaneously. And you think about quantitatively adding laws together to get your results. But that is not the case. As soon as you get into the more complicated situations, you don't get the answers on the laws by adding laws from a lower level together. You actually transcend the level you were working at, and you enter a new level where qualitatively wholly new things occur that have never occurred before. And frankly, you can never explain the wholly new just in terms of an immediately preceding set of laws.
I guess levels is an interesting thing to bring in here, because arguably you could say physics and the lower level sort of sciences are such a radically different level of reality to the social and historical and economic forces which led to Marxist ways of thinking, that you might think that they're chalk and cheese. They're from different universes almost. Where do they meet? And I guess it is to do with the things that you're talking about. But how can you apply Marxism to physics? I mean, I think it's particularly odd and interesting that it was in fact it was physics that led you to Marxism. I don't think many people would have that story.
Indeed.
But yeah, I mean, are these two levels too far apart to be?
No, indeed they're not. Indeed, as you quite rightly said, it was when I was just gone to university to study physics as a degree level subject, that I found I disagreed with the way it was being taught by my lecturers. Having been taught for something like 7 years in grammar school by teachers who mixed together property theories from chemistry with the relationships between variables from physics. And with those two disciplines integrated together, you actually could explain the reasons for certain properties. And what I found when I got to university was you couldn't do that anymore, because they restricted the contributions to explaining the world purely to physical law, and thought that you could do it by purely adding laws together. The answer was no, you couldn't. So I was forced to hit the library and try and find a work that agreed with me, and I did. I found one called Materialism and Empirical Criticism that criticized the usual way of dealing with physics, and suggested a way in which you got qualitative change emerging, which never happens in traditional physics.
So this was the book by Lenin.
Yes.
I mean, I guess most people, probably even most Marxists, don't even know that Lenin wrote a book about physics.
They certainly don't.
And from what you've told me before, I know that you went to communist organizations and tried to find other Marxists to discuss this with, but none of them really had much to offer in that regard.
No, indeed. In fact, I was very disappointed. This wonderful book by Lenin, which he began writing in 1908 and finished in 1909, was exactly what I needed in my first year at university, trying to study physics, and an able critique of the way that my lecturers were wrongly limiting the study of physics to purely physical law and not bringing in any other disciplines. Whereas in my school, where we had very, very good teachers, they used sets of disciplines brought together to explain things. So, for instance, they never just taught physics as physics. They also used laws taken from chemistry so that you could bring in the properties of substances. Once you start mixing the disciplines, you were able to explain all sorts of things you couldn't explain within a single discipline. That is what is needed, and that is what generally isn't done.
And I don't suppose you can really get a more radical mixing of disciplines than mixing Marxism and physics.
No, indeed.
I mean, I think, I think I think there's a greater relevance for this work to people's lives than they might at first assume. These could be considered, particularly abstract and way out things by many people. But I think you're often keen to relate what you're doing to the current political situation to show that these ideas about the nature of reality are not just applicable to subatomic physics, but they're applicable to everything. Hence, the systems theory of everything being the last publication that we made. The next bit of the article I've pulled out here talks about Ukraine. It says, A minor war in Ukraine, similar to many that, for example, the USA regularly indulges in, but without the whole world system having to be purposely and consciously put in existential jeopardy, as is the case here. For the current system instability, most certainly threatens to be a repeat of the Second World War, when both sides were also capitalist powers seeking hegemony, and the capitalist dominance of the world turned out to be at stake then too. And one of the other things that we've talked about is also climate change. So these are the biggest issues of now that are crying out for dialectical understanding. They're crying out for a holistic systems understanding before they reach the point of being existential crises. But there's no theory there to help people work out what's going on.
The trouble is that people don't know where to look. I mean, if you're a physicist, you look in physics and try and find everything in books on physics, right? But every single book that's written on physics is limited to kind of ordinary laws, quantitative laws, what they call empirical laws. But if you look outside of physics to, say, chemistry, you'll find that in chemistry, they talk about substances and their properties and how the properties can change when they interact, when they combine, when they melt, when they boil, when they burn. So the point is that there's already a possibility of getting causality into physics by mixing the discipline of physics with the discipline of chemistry, say. It's certainly the way I was taught, both of them, when I was at grammar school. But when I got to university, it ceased to do that because they were working in the subatomic realm. The difficulty we have is in finding other disciplines that relate to one another with entirely different systems of laws. That's the way that you transcend the single discipline way of looking at things. You've got to bring, like we brought together chemistry and physics, you've got to do the same in all these other areas. And nobody's looking outside of their area at all.
I suppose the other problem you've got as well is that most disciplines, with some exceptions, are hamstrung by that sort of myopia, but also reductionist ways of working, reductionist assumptions. And what we're really talking about here is looking at a much bigger picture. It's not just about wedding reductionist disciplines together, because that's exactly the kind of Lego mentality that we're trying to move away from. It's about seeing things at a much grander scale, isn't it?
Yeah, and it's also qualitatively different. You see, when you're doing the normal methods of doing sciences, you think that lower laws can be added together to make more complex laws. You know, the higher laws are productions from lower laws. Now, that isn't enough. That won't produce everything. And what is different about the real world is that you can get situations where qualitatively new features appear for the first time. And when that happens, there is no way that you can use old-fashioned methods of explaining it. You couldn't use laws within physics to explain some of the things that was explained when I was at grammar school. And if you took the laws from a chemistry and used those, you couldn't explain it. In fact, it was when you used both that you could transcend the limitations of the individual sets of laws. The disciplines, as such, were inadequate. But when they were brought together, you were in a different world with different possibilities, and the wholly new could occur. So the problem we've got now is finding what parallel disciplines they're going to bring together.
I mean, the other thing that happens often when you bring disciplines together, though, is you get different answers from the different disciplines. You get contradiction because they're starting from completely different places. They're starting from different assumptions.
Are they
Starting
going
with
in different directions?
Yeah.
That's the most important reason why you get contradiction. The hardest part of all is to leave the well-trodden path and to try and relate two things that aren't supposed to be related. That's where the answer lies.
And
Always.
isn't it quite a kind of Marxian way to do things that, rather than run away from the contradiction, if you found a contradiction, you've found where the meat is.
Absolutely.
That's if everything's in concert, then you haven't found the contention, you haven't found the error, you haven't found the thing that's going to let you see deeper and,
Indeed, you seek out contention, really, because you know that in things which seem to cancel each other out and say no answer here, that's where you'll find the answer if you study it deeply enough and well enough and in enough various areas. It will be there. You actually have to seek out contention. Contention is what makes development. How do you think we get life from non-life? How do you think we get thinking from mechanism? It's got to arise. And it won't arise in terms of the very bases that you were using to try and understand it. It's in a new area. And that new area is always outside of the limited areas of the various components that are involved. Always. I mean, I did it with my teachers when I was at grammar school. They did it. They managed to use chemical laws of properties of substances, in chemistry, and laws of relationships of other variables in physics, and between the two, explain certain qualitative changes. They did it. These are ordinary teachers in a school, but they didn't do it at university because by then they'd moved out of an easy area of relationship between the two sciences, and they were in subatomic physics, for example, and they never found another discipline to use alongside the subatomic physics discipline.
I guess this could lead us on to a kind of contention between a Hegelian and a Marxist way of viewing things, because if we assume that the reason why we get contradictions in the different disciplines is because of an error we've made or that we're seeing things incorrectly, that's a different assumption to saying that contention is part of the nature of reality itself.
Very different.
So are we mixing up two different kinds of contention here? Are we conflating them?
Oh, I don't think so. You've got to remember that there are many, many layers in society, many, many levels. And we don't really address the levels very much. We have a few that we've identified, and we stay within them. We don't go beyond the levels. But once you realize that there are levels and there's moving between levels, these sort of things are addressable. Contention is if you're comparing two levels as if they're separate. Right? But if you take those two levels and say, how do they relate to one another? How can one change into the other? Then contention reveals a truth that was invisible when you looked at the separate disciplines as they stand.
And I guess that has parallels, if not in some instances the same thing, whether that's a natural contention between two levels of reality or whether that's a contention between our study of different levels of reality. It's still born of the fact that we're not dealing with levels properly.
We don't even recognize them, really. We just consider that you've got separate disciplines that are laws unto themselves and don't relate to one another. That's not true.
So I guess one of the key points that we're here to make with this kind of new series on the nature of reality is that a fundamental part of the nature of reality is this division into levels, and a fundamental part of our problem in science and other disciplines is that we don't understand, acknowledge, seek out those levels and understand and work out what's going on in what level. That's just not something that's ever done, really, is
We
it?
make them prohibited barriers beyond which we cannot go. We separate them out as completely individual, separate things with their own laws and everything, that you cannot go from one to the other. But of course, that's got to be untrue. I mean, how the hell out of a human being can a new human being be created and be born? How does that happen? The amazing thing is that it couldn't happen unless you had two sexes. And the two sexes produce different things that when they unify, produce something wholly new.
It's almost thesis, antithesis, synthesis. The contending things come together to form something new, yeah.
But I mean, that's every day. Everybody knows that
course.
you get offsprings by the two sexes contributing to them.
That's
But
so,
think what that means. So
well,
that's a fantastically amazing situation. And what you get is wholly new. It's not an exact copy of either of the two contributors, is it? It's wholly new.
and perhaps it's, this idea that two things need to come together, perhaps in some contention to make something new, seems to be embodied in the duality of a lot of things in nature, like matter and antimatter, or positive and negative charges, or there's so many things that have a dualism that
Absolutely
have
correct. Here's a question, Mick, that no one answers. Why do you have positive and negative?
literally no one knows the answer to that.
Do
do
they heck? Nobody's got any idea.
That's a pretty fundamental question about the nature of reality that we don't know the answer to.
But even though we don't understand it yet, a dialectician would say, oh, yes.
Well, it almost seems to embody
I'll bet you there's something in that. I bet the positive and negative can do something wholly new. And they do.
I think if we sat here and thought of examples of other contending forces that form a unity, we'd be able to find hundreds of them. And that,
It's what should be taking place in universities and isn't.
but also that it shows. I mean, we started this conversation with some skepticism, almost on my part, of how we can bring a discipline like physics together with a discipline like Marxism, which is often high-level social, political stuff. And I think by the end of this conversation, we have come to a point where we're talking about those two things together, because we see contention, we see these forces happening at all levels of reality. And that's what we need to investigate, isn't it?